Hey everyone, welcome to EduKaji. If you're the first time here, let me introduce myself. My name is Walter and I'm a real-life scientist as well as a chemistry tutor for the past 8 years. So I specialize in chemistry lessons. And today's lesson or today's video will be based on the past trial paper for year 2021. This is the Kedah paper, first set. We're going to discuss the module 1 for paper 1. So without further ado, let's take a look at the first question. So for the first question, the question asks, who discovered the proton? So the answer here will be Ernest Rutherford, which is D. For second one, chemical formula of copper 1 oxide is, so copper 1 is carrying a charge of plus only. So in this case, you remember oxide actually carries a charge of O2 minus. So in this case right now, since plus 1 is for copper and minus 2 is for oxygen, you can just cross the number for each other. So if you swap the number, you get the formula, which is technically Cu2O. So the answer here will be C. For number 3, which of the following elements are transition elements in the periodic table of elements? So transition elements refers to the block of elements from group 3 all the way to group 12. So in this case, the answer here will be C, copper and platinum, while the rest of it is not exactly all of it in transition element. So this is the best answer to describe the transition elements. Number 4, what is the meaning of dative bond? Dative bond is also known as dative covalent bonds, where the for these dative covalent bonds to be formed, there must be a lone pair of electrons donated directly to another ion with an empty valence shell. So in this case, the best answer to describe that particular situation will be B, where you see over here it says a bond formed when an electron pair is shared comes from only one atom. For example, if we take a look at ammonia, so if you take a look at ammonia, nitrogen supposedly has 5 electrons. But what happens here is that it only shares 1 electron each with hydrogen. So this causes the nitrogen to have an extra excess of technically 2 electrons, which we call it as a lone pair because it's a pair of electrons that's not bonded to anything else, right? So in this case, right now, you can see that nitrogen itself has another 2 extra electrons on top. So if there's a hydrogen ion with an empty shell, it can actually come in here and share the 2 electrons directly, and then it will be able to form a dative covalent bond. So then you will come in and share these 2 electrons directly to form this dative covalent bond. So there's notice that the nitrogen atom actually it's actually sharing the 2 electrons directly with the empty shell of a hydrogen ion. So that's what we call as a dative covalent bond. All right, so the answer is B. Number 5, when silica is heated together with other chemicals, various glasses with different properties are produced. And they have the same basic properties. So which of the following is a basic property of glass? So the basic property of glass is obviously waterproof. Okay, none of them are actually able to dissolve in water, we'll say. Okay, so any water, any liquid that pours towards it that's water-based, it will not be able to dissolve silica. So therefore, it is actually waterproof. Not all glasses are heat conductors, which means some of them, basically all of them are heat insulators in a way. They're also not water permeable, and as well, they're actually not hard and strong. They could be hard, but they're brittle, right? That's why glass actually break quite easily. So B, C, and D actually doesn't explain properties of glass. Only A can be used as a definitive answer for glass itself. So the answer for number 5 will be A. Number 6, which of the following substance is a natural polymer? A natural polymer is a polymer that actually produced by living things. So the first thing that we see over here is we know that it must be produced by living things. That's why it is known as natural polymer. So polypropylene is produced by propene. Propene is actually produced by petroleum. So this is not. Polyisoprene, yes, this is actually rubber. So we know rubber is actually a natural polymer made by rubber trees. So that's the answer. Polyethylene and polystyrene, they are both also from petroleum based. So they're not actually natural polymers. They are man-made polymers. So A, C, and D, they are man-made polymers. They're most of them plastics. While B, polyisoprene is actually rubber, again, natural rubber. So the answer is B. Number 7, which of the following shows the correct classification of treatments of cosmetics? Okay, so over here we notice is that it's mascara, a treatment cosmetic. No, right? A mascara is something that you put into your eyes. Not into your eyes. I mean, I'm a guy, so I'm not sure about what mascara is used for, but I do see girls use mascara. And if I'm not wrong, technically, a mascara is something that you actually put on your eyelashes. Okay, if I'm not wrong. Okay, and that's actually to enhance how your eye actually looks, but it's actually not a form of treatment. All right, it doesn't actually treat any diseases whatsoever. So this is not classified as a treatment cosmetic. Okay, now cream, yes, because some creams are medicated, and those cream can be in a form of maybe, for example, antifungal drug. Okay, where you can apply it on your skin to kill off the fungus in your skin to prevent diseases such as what's it called, athlete's foot and so on, all right, or ringworm. So cream can be actually medicated and it can become a treatment cosmetic. All right. What about deodorant? And deodorant also doesn't actually help in terms of treatment cosmetics. Deodorant is just to make yourself smell better after sports. For example, maybe you smell a little bit weird because of the sweat that you produce. So it only enhances smell, doesn't consider as a treatment lah. Okay. And number 4 over here, it becomes a skin moisturizer. Now, the skin moisturizer treatment cosmetic, I'll say yes. Why? Because skin moisturizer is for people who have dry skin. Like for example, if you have eczema attack, all right, and the person will scratch like crazy and then they have bleeding. So the reason why is because their skin is extremely dry. So for people with dry skin, they normally apply what we call a skin moisturizer, and it's able to moisten the skin, and it will prevent cracks, it will prevent any itchiness from forming. So the best answer here will be 2 and 4, which is C. Okay. Number 8, diagram 8 shows the standard representation of sodium atom. All right, we have the nuclear number over here, and we have the proton number at the bottom over here. And this is the name of the symbol of the element. Okay. Now it's asking you what is the number of valence electron of the atom. So to know number of valence electron, you must first know the number of electrons that it has now. So you can see that, like I said, this is actually the proton number. So in a neutral atom, all right, in a neutral atom, number of protons is equivalent to number of electrons. Okay, so therefore we see here, right, if sodium has 11 electrons, sodium has 11 protons, it should also have 11 electrons. So if sodium has 11 electrons, then the electron arrangement of sodium will be 2, 8, 1. All right, 2, 8, 1. And the final shell, the last shell, is actually only 1 electron. So the number of valence electron, which is the number of electrons in the outermost shell, is actually 1. So the answer here will be A. Number 9, diagram shows the structural formula of propene. What is the empirical formula of propene? Actually, you can take a look at the general formula of alkenes. Okay, alkenes generally have a natural formula, a general formula of CnH2n. Okay, which tells you that for every 1 carbon atom, there will be twice the number of hydrogen atom. Okay. So if we take a look at the formula of propene, right, the molecular formula of propene is C4H8. If we divide both by 4, you realize that the empirical formula is CH2 lah. Right? So it corresponds to the general formula where you see the number of hydrogen atoms to carbon atoms will be 2 to 1. So therefore the answer here will be board. Number 10, the following chemical equation represents a reaction between sulfuric acid and sodium hydroxide solution. So sodium hydroxide reacts with sulfuric acid to give you sodium sulfate and also water. What is the volume of 0.5 mole per dm cube of sulfuric acid required to neutralize 25 cm cube of 0.1 mole per dm cube of sodium hydroxide? Okay, this is very simple. Let's take a look at number of mole of sulfuric acid, or should I say the number of mole of sodium hydroxide. Okay, so I think because we have the data completed for the sodium hydroxide, so we can calculate number of mole of sodium hydroxide and compare in terms of ratio. So number of mole of sodium hydroxide you can just use the formula MV over 1000. So that is basically 0.1 times 25 divided by 1000. So let's see how much that is. So what I got on my calculator will be technically 0.0025 mole. Okay. Now, in terms of ratio, the ratio of sulfuric acid required to sodium hydroxide is 1 to 2. So currently what we have is we have the number of mole of sodium hydroxide and it's 0.0025. So to get the number of mole of sulfuric acid, it is basically half of that. So you have to take the number of mole of sulfuric acid. In this case, will be 0.0025 divided by 2. And the number of mole of H2SO4 is 0.00125 mole. Okay, now we have the concentration already. Now we just have to get the volume, given that the number of mole is 0.00125. Now the original formula for this question, to get the concentration, right? Usually we see concentration is equivalent to number of mole divided by volume. But because now our goal is to get volume, isn't it? Our goal is to get the volume. So what we're going to do is we're going to reshuffle the formula, where right now what happens is that volume is equivalent to number of mole divided by volume. So now number of mole not volume, sorry. Number of mole divided by concentration. So number of mole will be 0.0125 divided by the concentration of the acid, which is technically 0.5 mole per dm cube. Okay. So let's see how much that is. So 0.00125 divided by 0.5. The answer will be 0.0025 dm cube. If you were to convert this dm cube into cm cube, it will be 0.0025 multiplied by 1000. If you do that, you'll get exactly 2.5 cm cube. So that's how you work out the solution. And the answer is technically, C. Not D, sorry, C. All right, number 11, table shows the solution P, Q, R, and S with their pH value. So we have pH 3 for P, 7 for Q, R 9, and S 11. Which of the following solution reacts to magnesium to produce hydrogen gas? So right now we will say that if you want to react with magnesium to produce hydrogen gas, it must be something which is acidic lah. Okay, so definitely the answer is P law, because only P shows an acidic solution. All right. Q is neutral, doesn't react with magnesium. R and S are both alkaline substances. They will not react with the magnesium at all. Okay, so the only possible substance over here that can produce hydrogen gas with magnesium is actually P, which has a acidic pH value. 12 rate of reaction is measured in the changes in the quantity of reactants of products per unit of time. What is the correct unit of the rate of reaction? So rate of reaction must have either a change in the volume or the amount of reactants or products over a specific time. So for number 12 over here, the best answer to describe the situation will be D, because it refers to cm per cm cube per second. Okay, the rest of it is actually wrong. This looks very weird. So the only possible answer here will be donkey lah. Number 13 diagram shows the arrangement of atoms in pure metal and alloy when a force is applied. So the first part you can see at the top picture, it is actually referring to the malleability of a metal, a pure metal. So pure metals are very malleable because they have this regular arrangement of atoms which can actually slide across the layers, and it causes it to be very less strong, I would say. Compared to an alloy, you can see over here, they actually have foreign atoms inside, which actually disrupts the regular arrangement. So therefore, they will not be able to slide that easily. Okay, so which of the following is most accurately described the properties of pure metal and the alloy? I would say the best answer to describe this particular situation here will be boy, which is the pure metal is ductile compared to the alloy. The rest of it is actually technically, in a way, it's true. Like pure metal is indeed softer than alloy. Pure metal is malleable than alloy. So all those are considered as an possible answer. Okay, but I would say to a certain extent, if you want to stretch it into wires, then the answer will be ductile. If you want to make it into sheets or like aluminum sheets or different kinds of metal components, then perhaps you can choose that pure metal is technically more malleable than an alloy itself. Okay, so this is just an example to show you. 14 again shows the apparatus set up for a Daniell cell, and E0 value for the 2½ cells is shown over here. So which of the following is the cell notation of the chemical cell? So we start with the left side now, which is the zinc electrode first. So I would say here A and B is out already. And then make sure that if you were to put zinc as your first part, always remember that you have zinc followed by a boundary, and then zinc ions, followed by the concentration correctly. And after that, what happens is that you have your copper, right? Copper ions inside the solution. But remember that copper, after that, will accept the electrons, because here, after that, copper will accept the electrons to form the copper atoms. So the best answer here to describe number 14 here will technically be C, okay? Where you see that zinc solid becomes zinc ion, and copper is then turned to copper solid. Copper 2 is turned to copper solid. So that is cat. Number 15, the diagram shows the structural formula of ester that produces the fragment smell found in green apples. Okay, so Alia wants to prepare the ester in the laboratory. Which of the following she can use to prepare the ester? Okay, what they did was they give you the picture, the structural formula over here. You just need to know what's the monomer for the, not monomer, sorry, the two small molecules that makes up the particular ester. Okay, so in this case here, you will see this kind of structure. The midpoint, or should I say the branching point off from the alcohol, the carboxylic acid, is located over here. All right. So before that, this is actually a butanoic acid. All right, and then on the right side over here, you can see this is supposed to be methanol. So if you were to mix butanoic acid and methanol, then you'll be able to get your ester of a choice. Okay, very simple. So Alia wants to prepare the ester in the laboratory. Which of the following can be used to prepare the ester? So I would say to prepare the ester, you need one particular acid and carboxylic acid and one particular alcohol. So the best answer here, there's not got one, methanol and butanoic acid, right? So methanol and butanoic acid will be the best choice. So number 15 is A lah. Okay, we already named this already. Left side is actually a 4-carbon carboxylic acid, and the right side is actually a 1-carbon alcohol. That's it. Number 16, Zara add a spatula of ammonium nitrate powder into a beaker. The beaker becomes hot. They wish the following composition. Okay, now, what happens here is that Zara had added a spatula of ammonium nitrate powder into a beaker filled with distilled water. So that's supposed to be an endothermic reaction, because we know that whenever you dissolve any ammonium-based salt, you get a you actually get the basically I was saying now, sorry. Zara add a spatula of ammonium nitrate powder. If you were to add any ammonium nitrate base or any ammonium salt into water, it creates an endothermic reaction to absorb heat from the surroundings. So that's why number 16 over here, the best answer to describe, which one can explain the chemical phenomena. I will say that this is actually supposed to be A lah, okay? Heat is absorbed from the water itself. For the question number 17, photochromic glass is produced when glass is combined with silver chloride and the copper 1 chloride. When exposed to sunlight, the photochromic glass darkens. Which of the following is the Huff equation that describes this particular phenomenon? So for this kind of phenomenon, what happens is that silver ions will accept the electrons to form silver atoms. Okay, because you see, right, you can see that the two substances that make up photochromic glass is actually the silver chloride and the copper 1 chloride. Okay, like this, like because silver chloride is actually photosensitive, which means it's sensitive to sunlight. So it will technically break down. Silver chloride will break down to form silver and chlorine gas in this particular mechanism. So therefore, nothing really related to the C, but more towards A and B lah. However, if you see, right, the equation for A is actually wrong. Why? Because you see here, in order for you to form chlorine gas, you must technically have Cl2, okay? So this one, just explain about Cl, then it's not so accurate lah. So therefore, we'll choose B instead, because it is Ag+, which is the argentum ion or the silver ion, accepting the electrons to form silver atoms. For number 18, diagram shows the structure of the polymer Q. It's a very long chain polymer. Which of the following is a property of polymer Q? So this one over here, I would say the best answer for number 18 here would technically be B, okay? Why? Because this is referring to a type of plastic, okay, type of plastic that can be repeatedly remolded upon heating and can be recycled, right? So this is just one particular answer to show you, like it is type of plastic that can be remolded and it can be heated and it can be recycled as well. So that's number 18. All right, number 19, which of the following solution have the same number of hydrogen ions as in 50 cm cube of 0.1 mole per dm cube of sulfuric acid? Now, the concentration of sulfuric acid, you must understand that the sulfuric acid is a diatomic, it's a diprotic acid. So for sulfuric acid, right, if you were to ionize it in water, what will happen is that they will actually dissolve in water to produce twice the number of mole of hydrogen ions compared to other acids, right? So we have to calculate number of mole of the acid first, and then calculate the number of mole of hydrogen ions. Then only we'll be able to compare individually which one has more hydrogen ion, which one has lesser. So to calculate number of mole of sulfuric acid, we have to use MV over 1000. So over here, we will have 0.1 mole multiplied by 50 cm cube, and then divided by 1000 and see what is the value over there. So 0.1 times 50 divided by 1000. The answer here is supposed to be 0.005 mole. Right, so 0.005 mole of sulfuric acid, okay? But the number of mole of hydrogen ions is different. You can see here for every 1 mole of H2SO4, you get 2 moles of hydrogen ion. So therefore, if you have 0.005 mole of H2SO4, your number of mole, okay, number of mole of H2SO4 will be times 2. So therefore, your answer here will be your number of mole, oh sorry, this number of mole of H plus. Right, number of mole of H plus will be 0.01 mole. So now your job is very simple. All you have to do is just calculate one by one and see which one has the same number of mole of this as this particular H plus of H2SO4. All right. So number 1 over here, if you calculate and see all of that, you can use the formula MV over 1000. And then you get the number of mole already. So for let's just take a look at atomic acid. 0.1 multiplied by 100 divided by 1000. So you will get 0.001 mole. Same goes for the rest, okay? 50 cm cube. So you got 0.1 mole per dm cube multiplied by 50 cm cube divided by 1000. And you realize that this is actually supposed to be, for number 2, it will be 0.005 mole. And then do keep in mind that phosphoric acid is a triprotic acid. So you get 3 times the H plus per molecule, right? And then for the next one, 3, you can see here 100 and 0.1 hydrochloric acid. So 0.1 times 100 divided by 1000, you get 0.01. And the last one will be nitric acid. So there will be 0.2 times 50 divided by 1000. You also get 0.01. Okay, now comparing all of this, right? You will definitely say that okay, 1, 3, and 4 can be the answer. However, is it true? Now, number 2 is out already because you know why? Even though you have a triprotic acid, phosphoric acid is a weak acid. So you will not be able to dissociate completely, give you what you want also. So therefore, 2 is out. And 1, 3, 4 may seem the same, right? All 0.01. However, if you notice that this is ethanoic acid. Ethanoic acid is a weak acid actually. And if it's a weak acid, then what happens is that supposedly it will only dissociate or ionize partially in water to produce lower concentration of hydrogen ions. So therefore, 1, although it has the same number of mole of the acid, it will not have the same number of mole of H mass. Definitely be lesser compared to strong acids in this case. So the best answer here still will be 3 and 4. And the answer here will be D. 20 diagram shows the structure of rubber T. Which of the following is the property of rubber T? So I would say over here the answer is supposed to be C, elastic, because this is supposed to be a vulcanized rubber. All right, a vulcanized rubber is the one that contains the cross linkages already. All right, so it is not sticky when it's heated because it's heat resistant. All right, it is also not easily oxidized because it is reinforced already is better. And it's definitely harder compared to natural rubber, so it can be soft also. But it is indeed elastic, right, for the rubber itself. So therefore, we will say that the answer is C. 21, which of the following are similarities of isotopes of the elements? Okay, similarity between isotopes. So isotopes are substances which can, which have the same number of protons but different number of neutrons. So I would say in terms of their similarities, okay, they should have the same number of protons. So number 2 is definitely correct. They should also have the same chemical properties. Why? Because they all have the same number of electrons. If they have the same number of electrons, they should have the same number of valence electrons. So therefore, the answer here will be D, right? 2 and 4. Physical properties and neutrons are different. I cannot, okay, because we know that isotopes are atoms of the same element with the same number of protons but different number of neutrons. So definitely you can do this. And physical state or physical properties will not be able to stay the same also, because why? Maybe one of the atoms is heavier than the other, so then the movement speed will be affected and things like that. So the answer here is still the best for donkey. Okay, all right, next. Which of the following electron arrangement represents element in group 13 in the periodic table elements? For group 13, all you have to do is just to look out for atoms which have 3 valence electron. So number 4 has 3 valence electrons, and number 1 has 3 valence electrons. Because why? Group 13 elements should have 3 valence electrons. So therefore, the best answer here will be 1 and 4, boy. 23, which of the following pair of physical properties is correct about magnesium chloride? Okay, magnesium chloride is supposed to be an ionic compound. Okay, it is an ionic compound. So for this question over here, is it soluble in water? Yes. Does it conduct electricity in molten state? Yes, because it is a compound, not an element, right? So A is definitely correct lah. It is soluble in water and it is able to conduct electricity in a molten state. The rest of it is wrong technically, okay? Because those are not things that is pointed towards an electrical, it's not electrical, sorry, a particular substance that is related to this particular subtopic. Number 24, which of the following occurs in reduction reaction? So oxidation and reduction has 4 different main definitions. Okay, does it gain oxygen? No. Does it loses hydrogen? No. Does it gain electron? Yes. Does it increase oxidation number? Wrong. So the best answer here will be C. 25, Anas opened the freezer, all right? In the shop to buy an ice cream, you can see the dry ice in the freezer change into smoke. So what's the process and the energy change across the dry ice? I would say the energy change will be technically, in this case, for now, will be sublimation, of course, because you see, it says here, dry ice, okay? Dry ice changes directly into a smoke, right? So that's not magic, technically, it's just sublimation. And among all these questions, you can see, right, all the answer they give you, ABC does not have the word sublimation. So definitely this one is actually wrong. But let's take a look at the energy content. So energy change. Does this, is this accompanied by energy change? The answer is yes. For you to break free from a regular arrangement, you need heat energy to be absorbed. So therefore, this is supposed to be correct. Sublimation and also energy is absorbed. That's it. 26, which of the following reactants can be determine the rate of reaction by measuring the change in volume of gas per unit of time? So we want to calculate the rate of reaction by the change in volume of gas per unit of time. Okay, so which one can actually help you to get this working? I would say the answer here is very simple. Look out for the answer which has gas production. If there's no gas production, there's no point. The first reaction got no gas reduction, no gas production technically, right? So in this case here, acidified potassium manganese solution with sodium bromide solution. So even though bromine is produced as a side reactant, as a side product, but it is actually not in a gaseous form, right? Bromine turns to bromine water. So therefore A is out. Sodium hydroxide and concentrated sulfuric acid. So this reaction got no gas being produced. It's just a neutralization reaction. You only get salt plus water. So therefore out. C, calcium nitrate solution with sodium carbonate solution. This will create an insoluble salt, all right, but it doesn't really help in terms of calculation of rate of reaction, except for the last one. Okay, calcium carbonate with hydrochloric acid. Why? Because you see over here, this one produces a gas. If you have calcium carbonate reacting with hydrochloric acid, you'll be able to form calcium chloride, carbon dioxide, and also water. So here you can see there's a carbon dioxide gas being produced already. C doesn't have a gas because the carbonate over here will combine together with the calcium to form calcium nitrate. Right? So that's technically not accurate. Best answer will be donkey. 27 diagram shows the setup of the apparatus to prepare compound X. So we have acidified potassium dichromate 6 solution plus ethanol. And then you have this substance being produced, new substance being produced in the boiling tube that is directed towards a beaker and inside the test tube, sorry. So which of the following is statement is true? Does it have the general formula of HCN, no, because you can see over here, compound X is supposed to be an a carboxylic acid. Okay, to be exact, it is supposed to be ethene, because from ethanoic acid, because if you were to technically oxidize ethanol, you get its corresponding carboxylic acid, which in this case will be ethanoic acid. Okay, so does it have functional group of carboxyls, COOH? Yes, the answer is yes. Reacts with magnesium to produce hydrogen gas. Does it really work? You ask yourself, does this particular substance react with magnesium to produce hydrogen gas? So of course, since it produces a carboxylic acid, it should be able to sort of like collect the gas, I would say. Okay, so you see over here, carboxylic acid does react with reactive metal, right? Acid do react with reactive metals. So for number 27 over here, I would say 3 is correct. It does react with magnesium to produce hydrogen gas because compound X is an acid. Number 4 reacts with hydrogen at 180 degrees Celsius in the presence of nickel to produce alkane. So this one cannot, I would say that cannot. Okay, so you cannot react a carboxylic acid with hydrogen. Okay, it doesn't make sense. So the best answer here will be C. 28, which of the following is correct about soap? The hydrophobic part, the soap dissolves grease. Hydrophobic part is the one that doesn't like water, and that will be the one that dissolves in the grease. That's what this is actually correct. Soap forms scum in soft water, false. Soap only forms scum in hard water, where it contains calcium and magnesium ions. Soap is prepared through the hydrolysis of fats and alkaline conditions. So in this case, of course, take a look at the answer, and it's correct. We'll say that soap is indeed prepared through the hydrolysis of fats in the alkaline solution. That's why you need a concentrated alkaline solution for this to happen. Okay, so the answer here will be 1 and 3. 29, 1.2 grams of X reacted with 0.8 grams of element Y to form a compound, the formula of XY. Okay, so here they ask you what's the relative atomic mass of X. So we have to know and see. Currently, we know that the formula of X, YX is or XY, we say is a 1-to-1 ratio. Okay. So let's take a look at this. For this part over here, so Y is 16, right? The molar mass is 16. So Y will be equivalent to, sorry, this one is different. So we have X and Y. So for number 29 over here, if you see, 12 grams is X and 0.8 grams is Y. Okay. So we're going to come and see what is the ratio of the two. So 1.2 divided by X and 0.8 grams divided by 16. And let's see how much you get. So it's 0.8 divided by 16. It'll be 0.05. So since you see, right, the compound has a formula XY, which is a 1-to-1 ratio. So 1.2 grams divided by X will technically be 0.05 as well. So then X will technically be 1.2 divided by 0.05. So 0.05. The answer is 24. So the answer is C. Now, this question is very simple, okay? What I did is that I technically got the formula already. So I'm reversing the empirical formula method just to get back what my relative mass of the X is. That's why I draw this table, okay? So when I compare the ratio, right, I have the information for Y. So I just divide straight away, I get 0.05. And I know that X is actually 1.2 grams. And because it's a 1-to-1 ratio of atoms, I will know that the number of mole will be the same, 0.05 and also 0.05. So by using this over here, we'll be able to work out what is technically X. And I found that X is actually supposed to be 24. So the answer is C. All right, 30, which of the following activities involves the formation of hydrogen bonding? All right, so when the person blows the paper and it lifts up, it's called Bernoulli's principle. That's physics. There's nothing to do with chemistry over here. What about this? All right, between two, the person is actually combing the hair. I would say the person is combing the hair. And the third one will be I have no idea what she's doing, but I am imagining that she's actually using her saliva to flip the pages of the books. You realize it's plastic stuck together, you cannot open up, or the book cover, you cannot open up properly. You take a little bit of saliva and you try to flip it over. So the reason why it works is because I know there's water on the book and there's water on your fingers. So if you were to touch the pages, of course, for example, the hydrogen bond will form between the water molecules on your hand and also the books and things like that. Same goes for number 2 over here. If you have very wet hair, there could be a possibility where hydrogen bonds can form between the water on the comb as well as the water on the hair itself. So therefore, the best answer here will be 2 and 3. All right, and the answer here will be C. 31, the following chemical equation shows the dissociation of barium hydroxide in water. So what is the number of mole of hydroxide ion in 250 cm3 or 0.5 mole per dm cube? So 0.2 mole per dm cube of barium hydroxide. So what we have is the volume of barium hydroxide and also 0.2 mole per dm cube of barium hydroxide. So we can just use the formula M1 V1 M2 V2. Sorry, MV 1000 was that? Sorry, yeah, MV 1000. So MV 1000, you can calculate, you can work this out. You take this one. So then it will be 0.2 times 250 divided by 1000. So number of mole of barium hydroxide is 0.05 mole. Okay. And because you see, right, for every 1 mole of barium hydroxide, you actually get 2 moles of hydroxide ions, right? So this is a 1, 1, and this is 2. So therefore, the number of mole of hydroxide ion over here will be 0.05 times 2. So 0.05 times 2 will be 0.1, all right? So the answer here is 0.1B. Okay, we are comparing in terms of ratio. Okay, for every 1 mole of this, you get 2 mole of this. So if you work it out correctly, you should be able to understand what I mean. 32 diagram shows the fractional distillation of petroleum. Okay, we got different fractions that's being produced over here. So we got P, naphtha, Q, R, then lubricating oil, and then followed by fuel oil. Which of the following is used as a fuel for heavy vehicles such as buses and lorries? So this is actually referring to diesel. All right, because only heavy vehicles actually use diesels. So diesel itself is also a part of petroleum. Okay, so the question now is, which of the following is used? So we have to know the location of where technically your diesel is. So in this case, then I'll give you the answer straight away. The answer is C, which is the section R, which is over here, C14 to C20. All right, that is the part where diesel will come up. So the answer is R. 33, which of the following is true about the meaning of the relative atomic mass This is in reference to carbon-12, of course, because carbon-12 is a, I would say, the benchmark, all right, or the reference atom to compare the relative atomic masses. So 33, the best answer to describe that particular term, right? The meaning of the relative atomic mass, in this case, will be A, okay? The average mass of one atom, okay? When compared with 1/12 the mass of carbon-12 atom. That is the definition of relative atomic mass in relation to carbon-12. 34, which of the following explains the meaning of effective collision? So effective collisions are collisions that end up with the products being formed. So the best answer here for number 34 will technically be A. Okay, so you see here the collision that causes a reaction. That's the main idea, right? Once you have a successful collision or effective collision, then you have more products lah. Okay, so in this case, the very simple answer will be that yes, okay, the effective collision is part of your rate of reaction. You know that it is based on a lot of factors, but we know that at the end of the day, right, effective collisions basically means that it will cause the reaction, right, the collision to move forward to produce products. So therefore, A is the best answer to describe a situation, okay, the collision that causes a reaction. All right, the following thermochemical equation represents the precipitation reaction between barium ion and sulfate ion. Which of the following statement is true about the above equation? So barium sulfate is supposed to be white, so this is wrong. Is it an endothermic reaction? No, because it is a negative value, so this is wrong. Heat is absorbed from the surrounding, also wrong, because we know that heat is being released more than it's being absorbed. So D here, final temperature of mixture is higher than the initial temperature, which is true. This is true. Why? Because it's an exothermic reaction. It's negative X kilojoules per mole. All right. So therefore, the answer is donkey. Final temperature of mixture is higher than the initial temperature. This indicates that this is an exothermic reaction. 36. Which of the following are correct about polymer and its uses? So polyethylene for plastic bottles, yes, the one that we always buy from the supermarket, the mineral water bottle, those are called polyethylene. That's technically correct. B, polypropylene water pipe, no, that's actually wrong. Polychloroethylene for food container, no. For food container, we normally use polyethylene also. And polystyrene, we use it for textile? No. We use it to make ice blocks, for example, to keep things cold. So therefore, the only possible answer here will be A, polyethylene corresponding to plastic bottles. 37, table shows the observation when oxide of elements in periodic table elements are added into water. So W2O3, you put that water, no changes, means that it dissolves. XO, you put that water, also no changes. Y2O dissolves to form a colorless solution. So based on this particular example here, which of the following is the correct statement, correct arrangement in the increasing proton number of the elements? So when we talk about the elements, right, we're referring only to the alphabets in front, which technically over here now will be W, X, and Y. Okay, so if you were to dissolve W2O3 and XO, no changes can be observed. But if you were to dissolve it in what's it called? If you were to dissolve it in water, if it managed to dissolve, then it must be a colorless solution over here. So what's the increase with the correct arrangement, the increasing proton number of the elements? So of course, we will notice that across period 3 for the oxides, if you were to react with anything else, supposedly the elements, they will react in terms of their electrons. So going from left to right, the reactivity of the elements will slowly decrease and then increase back again. All right. So you have to know how to arrange the elements correctly in the periodic table. So in this case, right now, the answer for 37 will be technically donkey, which is Y first, then X, then W. Okay, why? Because Y, you can see here, it dissolves straight away to form colorless solution. So it means it's very reactive. Okay, Then after the other two also, there's no reaction at all, right? XO, W2O, no reaction. So we have to choose Y first, followed by X, and then W. Okay, Y being the most reactive means from the left side, and then slowly, gradually. All right, you can see this one's in the middle, okay, supposedly. Why? Because W2O3 refers to a particular element like aluminum, for example, right? Because W2O3 means W carries a charge of 3 plus. So therefore, in this particular sequence, it's correct. 38, table shows the standard electropotential of the metal ion P, Q, R, and S. They are not actual symbols of the atom. Based on the above information, which of the following is the correct order of the increasing strength of oxidizing agent? All right, the more positive the value, the more likely it'll be the oxidizing agent. The more negative the value, the more likely it'll be the reducing agent. Okay, so based on this particular data that they give you, right, I would say that the one that's most negative will be the least likely to be an oxidizing agent. So they want you to describe in terms of increasing strength of oxidizing agent. So I would say the worst oxidizing agent will be Q. Okay, will be Q. Followed by the next one should be S, and then R, and then P. This is in terms of increasing strength of oxidizing agent. Meaning to say P is technically the best because it has a positive value. Okay, so I want it to be clear that the more positive it is, the more likely it'll be an oxidizing agent. So for this particular example, we are referring to the ion, okay, not the atom, okay, because right now, if you look into the standard electropotential table, all right, you need to refer to the ion. So the best answer here with number 38 will be donkey. Number 39, diagram shows the flow of gas liberated by heating zinc nitrate into distilled water, which contains a few drops of phenolphthalein. So zinc nitrate heated up, they will actually decompose, right? Supposedly zinc nitrate decomposes upon heating to produce zinc oxide, nitrogen dioxide, and also oxygen. All right, so that's the main equation that you get. But either way, you can see here, right? It produces nitrogen dioxide gas, in which when it dissolves inside the solution, the distilled water, and also with a bit of phenolphthalein inside, what happens here is that you should notice that there should be gas being produced, which is technically acidic in nature. So the best answer described 39 over here will be D. The solution remains colorless. So why is that so? It's asking why is the solution over here remains colorless? Because phenolphthalein indicator cannot show the presence of acid. Phenolphthalein indicator is only very specifically able to show coloration in the presence of the sodium hydroxide solution or any alkaline solution, but definitely not acidic solution. So therefore, the answer here will be donkey lah. Okay. And the last question over here, number 40, diagram shows the thermometer readings when excess magnesium powder is added into 50 cm cube of 0.5 mole per dm cube of copper 2 nitrate solution in a porcelain cup. All right, magnesium powder is then added into copper 2 nitrate. And what happens is that there's supposed to be a displacement reaction, okay, because magnesium is more reactive than copper, is able to displace copper out from its own salt. And then after that, you see the initial temperature of the solution is 29. After that, it rose up to 56. So what is the heat of displacement for the reaction? We're going to start off by calculating Q first. So Q is equivalent to MC theta. In this case over here, M will be 50 cm cube. Right, 50 cm cube. So total mass will be 50. We do not take account the magnesium. So 50 50 grams multiplied by 4.2 joules per degree Celsius, per gram per degree Celsius, multiplied by an increased temperature from 29 to 56. So 56 minus 29, you will get 27 in total. So the increment in temperature is technically 27 degrees Celsius. Yeah, right, 27 degrees Celsius. So just multiply everything together, 50 times 4.2 times 27. So the answer here will be 5670 joules. All right, 5670 joules. And then after that, convert it into kilojoules. Looks like it's easier. Just divide by 1000. Then you get 5.670 kilojoules. Okay. And then now you can calculate delta H. Delta H is equivalent to Q over N. We got Q already. We just need N right now. So N is the number of mole. Okay, number of mole what? Now you can see here we have one information that we get, which is this one. 50 cm cube of 0.5 mole of copper 2 nitrate solution. So just use back the same values. Okay, we're going to use MV over 1000 in this case. So in this case, we have 0.5 and 50. Okay, 0.5 and 50. Divide by 1000. So answer here will be 0.025 mole. Right, so 0.025 mole, according to this equation here. So just want to make sure that it's a 1-to-1 ratio. We're going to rewrite the chemical equation over here. So we have magnesium and copper 2 nitrate. So Mg plus CuNO3, you will get MgNO3 plus Cu, sorry. So it's a 1-1-1-1, or 1-to-1 ratio. So we can directly use this value over here as our number of mole. So right now, delta H is equivalent to Q over N. So that would be 5.67 kilojoules, divide by 0.025 mole. So the answer here will be negative 226.8 kilojoules per mole. So that's the answer, technically. So if you take a look at that, you will notice that the answer is supposed to be A. Okay. Now remember, it's an exothermic reaction. How do I know? Because we saw there's an increment in temperature from 29 to 56 degrees Celsius. So we know that this is an exothermic reaction. So make sure you remember to put the negative sign there as a practice. All right. So that's all for this Kedah paper number 1. I hope you guys have learned something throughout this discussion. And even if we don't actually learn this, or you don't get everything entirely, but you're still able to learn something, all right, or to do some revision over here. And I hope this will be able to help you with your exam. All right. So that's all for me today. I'll see you guys in the next video.